So let's try a quiz. We're going to do this quiz that we're not going to grade for. We're just doing it for practice. We're not going to grade it. But this one's for practice. So we have an electric field at location A due to charged particles nearby, and an electron placed at location A experiences an electric force of 4 times 10 to the minus 16, negative 6 times 10 to the minus 16, negative 3 times 10 to the minus 16 newtons. What's the electric field at location A? Okay, so we're placing an electron there, and the charge of a proton is positive 1.6 times 10 to the minus 19 coulombs. Okay, give you a few minutes to try that. Okay, so not quite as unanimous as I would have liked, but number 2 is correct. And what are we doing? We are finding the electric field based on the force on this electron. So we gave you the proton charge, but you got to remember that this is a negative charge, right? This is an electron here. So we have a force that's pointing, well, in some direction. Has a positive x component and negative y and z component. And so when you divide by, when you're using just one equation, simple equation, E is equal to F over Q, we have 4 times 10 to the minus 16, negative 6 times 10 to the minus 16, and negative 3 times 10 to the minus 16 newtons divided by an electron charge, which is negative 1.6 times 10 to the minus 19, and that'll flip the sign on all of the components, and so you should end up with negative 2.5 times 10 to the third, what was it, positive 3.8 times 10 to the third, and positive 1.9 times 10 to the third. Okay, and the units are newtons per coulomb. Okay? Real simple, just basic plugging in, understanding the relationship between electric field and electric force, and plugging in the values. Okay? Questions here? All right, so we won't grade that one, but if you got it wrong, make a note, because this is about as simple as it can get. Okay, it's about as basic as it can get. Okay, why don't we try just another quick question as well as a review, and we'll skip that one. We did an example last time. Let's have you try one. Here's a particle with a charge of negative 3 times 10 to the minus 9 coulombs sitting at the origin. We want to find the electric field due to that charged particle at 110 meters. Okay, so now we're going to use the second relationship. Take a minute or two, see if you can calculate the electric field at that location due to that charged particle. Drawing a diagram as your first step is absolutely critical in doing a problem like this, and it can help you check whether your numerical result is correct or not. The constant, what is 1 over 4 pi epsilon 0? It's equal to 9 times 10 to the 9th. Okay, so 81% of us are saying answer number 4, which is correct. Now, you could eliminate a number of possibilities right off the bat without having to do any calculations at all. Which of these you know just have to be incorrect? The ones with the positive values, right? Because if you draw a diagram and you place a negative charge at the origin here, okay, so this is negative 3 times 10 to the minus 9, and your observation location is at 110 meters, you know if it's a negative charge, the electric field has to be pointing towards the negative charge. And so without even doing anything, you know that it has to have a negative x component, negative y component, right? So get in the habit of doing that. Get in the habit of checking answers on physical and graphical grounds, not just by plugging in numbers, because it becomes absolutely important in this course. At that point, we need to find R. Well, R is going to be final minus initial, right? 110 minus 000, so that's just 110. the magnitude of that vector is the square root of 2, right? So the magnitude is 1.4 meters. And so r hat is going to be, 0.7, approximately 0.70. And it's a unit vector, okay? And so then we say the electric field is going to be 9 times 10 to the 9th times this negative charge, negative 3 times 10 to the minus 9. So don't forget the sign when you're multiplying here, because that gives you the correct values of the components, divided by 1.4 squared times 0.7, 0.7, 0, and you'll get back negative 9.55, negative 9.550 newtons per coulomb. Okay? Are we okay here? Questions? Okay, so this basic stuff, sort of the most basic stuff we'll be doing, calculating electric fields due to single point charges. Okay? All right.